idea of what happened, right? So how are we searching for it now? Well, we think that the whole plane has sunken underneath the ocean. And so what we're now doing is searching the floor of the ocean. And it's very hard to see down there. It's also very difficult to send people down there. So what we're doing is sending some machines down there that use sonar. Sonar essentially sends out sound waves, and those sound waves bounce off things, bounce back. And if you plug it into a computer, the computer will show you what it is that they bounced off of. So what we're trying to do is map out the bottom of the sea floor so we can figure out and see if we can find the pieces of this plane. This probably could take years, but that's what's going on. Now, why do I bring this up? Well, it's because of this technology here that was developed around the time of World War II, this sonar equipment, that we were actually able to make the next groundbreaking discovery in the theory of plate tectonics. So we left off yesterday with Alfred Wegener. And what was the fate of Alfred Wegener? What happened? What was the sad ending for him? What was the sad ending for him? Malik?
He had died, and he had died, and people still did, when he had died, people still didn't believe his theory.
Why didn't they believe his theory?
Because they couldn't find, it was impossible. They didn't know how the continents could have been.
So he provided the evidence, but he couldn't explain what?
How the continents.
He couldn't explain that. Today what we're going to talk about is how did we use the discoveries on the bottom of the ocean to actually explain how it is that the continents moved. By the end of the lesson, you'll be able to define what we call mid-ocean ridges, and be able to explain how their discovery gave us the evidence and the description needed for why it is that the continents moved. Please turn to the next page. In the 1950s, right after World War II, underwater mapping discovered large ridges in the middle of the oceans. Now these were parts of the world we had never seen before, we knew nothing about. We assumed that the bottom of the sea floor was flat, but what we found was that there were these ridges. So what exactly is a ridge? A ridge is a long, seismically active. Seismically active is basically just means that there's earthquakes. Underwater mountain system in the middle of an ocean and associated with the uprising of magma. This right here is a diagram. If you want to take a look, you see is this sort of like a mountain range right here, and magma is rising up in between, and if you were to go down there, you would experience a lot of earthquake activity. Now that was cool, right? We discovered these mountains, but there's not a lot more that can be said about that unless we can use it to maybe tell us more about the Earth's history. Now, I would like you to take a look at this map right here. If you can't see it on your page, just take a look on the board. This is where you are right here. This is North America. This is the coast. This is, we're a little bit further. We're about there. New York City. And then over here, this would be Africa, and then Europe. The colors, sorry, let me break this down. This is the ocean right here in between Africa and North America. This is the Atlantic Ocean. And this black line right here, right in the middle, is the Mid-Atlantic Ridge. So this is one of these ridges that we just talked about. Now what this map does is it tells you the age of rocks. So red would be very young, 0 million years old, and blue would be very old. Yeah. Green would be medium age. I want you to see if you can see a pattern here on the ages of rocks. What do you notice about the trend that's going on there? I'd like you to take 20 seconds. Discuss that with your partner. Do that now. 1 and 0. Sasha, what did you and your partner have in common?
When you said that on the coastlines of Africa and North America, they're blue, and it looks like they could put together. If you look at the green, like on the side of the red, you can see that these are blue and that's how it looks like it goes together.
Could you hear her over it? Can you speak that a little bit louder, Sasha? If you can sum that up, that'd be great. More voice, please.
On the coastlines of Africa and North America, they're blue and they're both old. So that most likely means that they matched up.
Okay. Somebody else, a different trend or maybe just a different angle of this description. Kaylee Walker, tracking Kaylee.
The further center they go, the younger they are. The younger the rocks are.
And the further away.
The further apart, the older the rocks.
Dorian, what was that relationship you just said?
She just said that the closer to the rock, the closer it is to the rock,
The ridge.
to the ridge, is the younger they are, and the further away, the older they are.
Cool. Kaylee, give it to me, Karen. All right. So, how did this help? How did this help? So, as you guys just pointed out, scientists observed that rocks nearest the ridge were very young, within the last 1,000,000 years. And that the further away from the ridge, the older the rocks became. Some of you are probably starting to form a theory in your head right now why this might occur. So let's go to let's continue forward and see if we can maybe explain what is going on. Why is this rock pattern occurring? So what we believe is happening here is something called seafloor spreading. The evidence suggests that the seafloors are spreading at mid-ocean ridges as magma rises up. So what we believe is that magma is coming up at the ridge, it's cooling very quickly, forming rock, and it's actually pushing the two plates apart. So if you were standing on North America, hey guys, this is you, and you had another, your best friend was standing on the Eurasian plate, over millions and millions of years, this would cause you two to go further and further away from each other. The spreading is likely pushing the continents further and further away from these boundaries. So as magma rises up, it pushes the plates apart, and it causes these people, or these continents, to move away. If only Alfred Wegener had still been alive. Because what this discovery did was explain what was causing the continents to move. And as soon as we discovered this seafloor spreading in the ages of these rocks, continental drift was accepted. Questions? Caleb.
So there's this thing in California that I'm not sure if it is a ridge, but it's like a couple miles long across like the desert or something.
The fault lines there?
That. Yeah. What is that considered a ridge or?
No, that's actually a transform boundary. So that's a different type of interaction. We'll talk about that in a couple weeks from now. But similar idea where plates are meeting. So quick check for understanding, hands down. What is it that is rising up at the Mid-Atlantic Ridge, Dorian? What was? Do we call it lava?
Magma.
Yeah, lava and magma are slightly different things. Let's be careful with our language. We know magma is rising up. What is this magma doing to the plates? Hands down. What is this magma doing to the plates? Elise. Tracking Elise? More voice? Spreading them apart. Yeah, I'm looking for a different word here. Yes?
Pushing up further.
Yeah, what word did he use that was different, Elise? Yeah, I think pushing might be a better word here than just be a little more precise. It's pushing them apart. All right, turn to the next page. Okay, we're going to read this control the game right now, of just this first part. So if I call on you, I'd like you to be reading. We will begin. Harry Hess was a geologist and Navy submarine commander during World War II. Dorian.
Part of his mission had been to study the deepest parts of the ocean floor. In 1946, he had discovered that hundreds of mountain ridges deep underwater shape the ocean floor.
Stop there. Please annotate what it was that Harry Hess discovered. Please read me off what you annotated, Elijah.
Annotated mountain ridges deep underwater shape the ocean floor.
Excellent. Continue reading. Continue reading. Abigail.
The discovery of the Mid-Atlantic Ridge in the 1950s inspired him to look back at his data from years before. After much thought,
He
he
proposed.
proposed in 1960 that the movement of the continent was a result of sequence studies. In 1963, he added a geologic mechanism to account for regular moving continent.
There's that word mechanism again. Where did we hear that word? Where did we hear that word before? Where did we hear that word, Sean? More voice, please.
Machine.
No, where did we hear that word before? We just discussed this word, I believe. Yes?
Why people didn't accept what it is.
Yeah, where did we hear this? Good.
Read it.
It was actually in the video, right? They were talking about they needed a mechanism. We discussed that a little bit. I'd like you to answer questions 1 and 2. Guys, number 1, eyes up right now. Eyes up. One of your objectives today is actually just to be able to describe or define a mid-ocean ridge. So question 1 is literally just asking you to describe what a ridge is. Okay? You don't need to tell me why they're caused or things like that right now. You just need to tell me what is a ridge. What do you need to tell me here, Taylor? Yeah, just define a ridge. And guys, yours is a little dark, so I've outlined on here where the Mid-Atlantic ridge is that they're talking about. Please answer questions 1 and 2. Question 2, you need to have textual support. We'll come back together in 2 minutes.